In healthcare, every patient generates a story. Parts of that story are captured in electronic health records, lab systems, claims platforms, imaging systems, and pharmacy applications. But some of the most important details live elsewhere in physician notes, discharge summaries, referral documents, scanned forms, clinical reports, and patient communications. The challenge is that this information is often fragmented across hundreds of disconnected systems, making it difficult for clinicians, care teams, and administrators to see the complete picture. That's why a Patient 360 view has become a strategic priority for healthcare organizations. Through data integration, organizations can bring together structured data from across the healthcare ecosystem, creating a trusted and unified foundation of patient information. At the same time, unstructured data integration unlocks valuable clinical insights hidden within documents, notes, and reports, transforming information that was once difficult to access into actionable intelligence. The result is a more comprehensive understanding of every patient. Care teams gain the context they need to make informed decisions. Administrators improve operational efficiency. Researchers uncover deeper insights, and patients benefit from more personalized, coordinated, and effective care. As you watch this demonstration, consider what's possible when every piece of patient information, structured and unstructured, is connected into a single trusted view. Because better data doesn't just improve systems, it improves outcomes. In this scenario, the data analyst team at a fictional healthcare organization called Lakeview Regional Health System wants to do some research on the correlation between breast cancer diagnoses and other health factors. A Patient 360 view is needed to do this type of analysis. Data will need to be combined and filtered from different tables and then loaded into the data lake. To complete the Patient 360 view, data must be extracted from PDF records of patient forms and doctor notes to provide additional information collected in the smaller urgent care facilities in the network. Let's see how IBM Watson X data integration can meet this challenge. Let's start by looking at the available data in our IBM DB2 cloud database. After clicking Data, Tables, and the Patient Records schema, we can select the Patients table. When we view the data, we see basic information about each patient, including the ID field that uniquely identifies the patient in other tables. Going back, we can choose the Conditions table and view the data to see health conditions for each patient linked to the unique ID. Now that we understand the data, we will go to Watson X data integration to prepare this data for analysis. Let's start this integration by going into our existing project and creating a new asset to transform and integrate data with DataStage. We'll call this flow Breast Cancer Research and click Create to go to the design canvas. We want to add two assets to the canvas, which are the two tables we viewed in IBM DB2. We'll use the connection to IBM DB2 Cloud and open the patient record schema and select both the Conditions table and Patients table before adding them to the canvas. We need to join these tables together using the unique ID, so we'll add the join processor to our canvas and connect both tables. Let's configure the join processor and add a join key. We'll use ID and apply and save our work. Next, we need to filter and keep only those records that have a breast cancer diagnosis. We'll add the filter stage to the canvas and connect it to the join stage. To see a preview of the data, we'll also add a peak stage and then connect the filter and peak stages. After opening the configuration pane for the filter stage, we need to add a where clause to this stage by using the calculator button to build it. Opening the input columns reveals the code column, which we will select and then copy and paste into the where clause. We'll complete the clause by adding the code for breast cancer and applying and saving our work. It's time to run the flow. When we look at the log, we see the records that passed through to the peak stage had the diagnosis of 254-837-009 malignant neoplasm of breast disorder, and this means our filter was applied correctly. We'll close out of everything and add our destination for this data. After clearing the search, we can open the Database Connectors menu and select IBM Watson X Data Presto, which we will connect to Peak. We'll make a few quick configurations to add the pre-built connection, the catalog, the schema, and the table. One more save, and then we are ready to run the final data flow. Next, we will switch over to watsonx.data to make sure our data has populated the data lake. Over in watsonx.data, we will select the proper catalog, schema, and table. After clicking Data Sample, we can see that only records with the breast cancer diagnosis made it to the data lake. Now that we have all the structured data in the data lake, we need to take on the challenge of integrating the unstructured data. Let's start by looking at a sample patient form. Back in watsonx.data integration, we will look at a PDF that has doctor notes, medications, and other important details we want to extract. This document is full of unstructured data that we want to add to our data lake, including the list of medications. Let's build a new asset to analyze and enrich unstructured data with unstructured data curation. We'll give it a name, save our work, and add our document from the project. After selecting it, we are ready to analyze the document. After a few moments, the document has been analyzed and we have an excellent result. This matched the existing medical information document class, which means we can easily extract data from the PDF into a usable format. Let's process the document. We have a few error messages, but that isn't a cause for concern. We need to set up our vector database and our entity database. For the vector database, we need to use the pre-built Milvus connection. For the entity database, we need to use the Presto connection with the Lakeview catalog and the research schema. No more warning messages, so we are ready to process the document. We'll save our settings and view the metrics of this job in real time. A quick resize helps us see all the steps, and we can watch the progress as each step is completed. After a few moments, the process is complete. Next, we'll jump over to watsonx.data to look at the newly created tables and data in our data lake. Back in watsonx.data, we'll use the data manager to open the catalog and schema to reveal the newly created tables. The PDF information related to clinical records, demographic data, diagnosis codes, and medications is now in our data lake. Let's review the medications table and see a data sample. Scrolling to the right shows us the 10 different medications that the patient takes. This information came directly from the urgent care PDF. And that's it. By combining structured and unstructured data, we can truly have a patient 360 perspective. As healthcare organizations continue to modernize, one challenge remains constant. Delivering better patient outcomes depends on having access to complete, trusted, and timely information. That's where IBM watsonx.data integration makes the difference. By bringing together both structured and unstructured data through a single intelligent integration platform, healthcare organizations can create the comprehensive patient 360 view that modern care demands. Whether it's integrating clinical, operational, and financial data through ETL processes or extracting meaningful insights from physician notes, discharge summaries, and other unstructured content, watsonx.data integration helps transform fragmented information into trusted intelligence. The future of healthcare depends on seeing the whole patient, not just pieces of the patient. With IBM watsonx.data integration, healthcare organizations can connect every source, unlock every insight, and turn data into better decisions, better experiences, and better outcomes for every patient. Thanks for watching.